Hi, I am Sohan Kumar. So from Lavi Info. So we will go for the training section for Linux device driver. So here we will go through all the topics what we will be covering for Linux device drivers. The first topic consists of types of OS, where we will learn about the kinds of OS available like monolithic, microkernel and real-time kernel. The second topic is Linux kernel architectures, where we will be going through the file hierarchy and what things placed which place, like in file system what all things are there, IO subsystem what all things are there, as well as in networking subsystem what all things are there. So these things is like getting familiar about the Linux kernel architecture. Now coming to the third chapter, that is introduction to device drivers. So here we will be knowing about what is user space and what is kernel space driver, what is the advantage and disadvantage of user space and kernel space. So these entire things we will be knowing about how to write a kernel space, what exactly things happen when we write a driver in a kernel space, what exactly things will happen when we write a driver in a user space. So this is all about introduction to device drivers. Then the fourth chapter is building and running the kernel modules. There we will be writing our first hello world module, and we will compile it and we will execute it and see how exactly the kernel module looks like and how to load it, how to execute it, what is INS mode, RM mode. Along with that we will be also knowing how to pass a module parameter to the Linux kernel module, like we usually pass integer values or character values when we insert the module. So here we will be knowing about the writing a hello world kernel module. Along with that, what else parameters can be passed to the hello world kernel modules. Then the fifth chapter is the character drivers, where we will be knowing about the major and minor numbers and some important data structures located in fs.h and all these things, how to write a character device, types of device drivers like character, block and network drivers, and for writing a character device drivers what steps we usually take, and what about the file systems, all these things, all the file operations. These things we will be knowing over here. So here we will be writing a serial drivers that in fact will take data from the user space right to the kernel space, and when the user will try to read data from the kernel space, the kernel will return the kernel buffer data to the user space. So here the serial driver will have open, read, write and close modules, and we will be simulating like how to write a kernel module drivers that interact with the user space. So then in advanced topic we will cover about the IOCTL, that is IO control, how to control what is IOCTL and what is magic numbers, how to form the commands using the magic numbers, and what is the use of IOCTLs. So these things we will be knowing. Along with that we will be knowing what is the blocking calls and non-blocking IO, and pull and select method, like pull module we will be writing and select method we will be using in user space applications, and we will see like how exactly things works for a character drivers. In this module we will also knowing about the IO mapped IO devices and memory mapped IO devices. So x86 architecture supports both IO mapped IO devices and memory mapped IO devices. So there we will be knowing about if any device that is connected to the x86 architecture, how to access those devices, what else calls to use to access those devices, and in case of ARM is memory mapped architecture, so what else calls are used to access any devices that is connected to the ARM board. So if I am talking about the ARM board, so all the hands-on we will be doing on BeagleBone Black as well as on Raspberry Pi. And if I say x86 architecture, so we will be doing on a desktop PC. So then the sixth chapter is interrupt handling. So here we will know about how interrupt works on x86 architecture as well as the on ARM architectures. So how to write an interrupt handler, for that how to write a bottom half, top half, then toxlates, yields, each and everything we will be knowing. And also about how to save the interrupt if it is being saved between, if any interrupt client being saved between so many devices, or else if an interrupt client is dedicated to one device, then how to write a drivers for that. So these entire things we will be knowing in the interrupt handling. Then in the seventh chapter we have a concurrency and race condition, where we will be knowing about how to write a drivers that can be accessed by the application, multiple application at the same time, and the code should be re-entrained. So how to write a re-entrained codes. So in order to achieve those things, how to use semaphore and mutex in your drivers, as well as what is the use of a spin lock, where to use a spin lock, where to use semaphore, where to use mutex, and how many types of spin locks are available. So these things we will be knowing in the concurrency and race condition modules. Now in the chapter 8 we will be knowing about the timer, delays and deferred work. So how to write a thread, how to write a timer function, how to provide a delay inside the kernel modules in the smart way, how to provide a delay inside the kernel modules. And in the deferred work, here we will be knowing about the toxlate, the work queues, then the soft IRQs, and the kernel timer, kernel thread, signals. These entire things we will be knowing in the chapter number 8. So you should not get confused with the kernel signals or process signals. So here we will be knowing about how the kernel sends signals to the user space applications and all the things. Coming to the chapter 9, that is platform driver and driver configuration. So basically the platform drivers, how to write a platform drivers, what is platform drivers, what exactly it is used for, then how to write a proc interface driver, then sysfs, syscontrol, debugfs, and then we will be having a hands-on, we will be writing a drivers in order to access those user data inside the drivers for procfs, sysfs, syscontrol. Then how to debug the drivers by using these above methods. So here we will be knowing about these drivers. Now up to chapter 9 we have written so many modules, so many kernel modules, so many modules that is being triggered by the user application using system calls, and we were not having any hardware. But now from chapter 10th we will be doing hands-on with the hardware. So now we will be knowing about the input subsystem. So how to write, what is input subsystem architecture, how to write input drivers. So for that we will be having hands-on on keypad device driver, that is a 4x4 matrix driver, then keyboard driver, that is PS2 interface driver, mouse driver, that is also a PS2 interface driver, and the touchscreen driver, that is the SPI based touchscreen driver, that we will be working on BeagleBone Black as well as on Raspberry Pi. Coming to the output subsystem, here we will be knowing about what is frame buffer, what is video file annex, where frame buffer is being used, where video file annex is being used, and we will be writing a graphic display drivers using the frame buffer driver interface or frame buffer subsystem. And then in serial driver we will be writing this driver on BeagleBone Black and Raspberry Pi as well as on x86 machine. So that is a UR driver. That driver consists of all the toxlate, bottom half, you can say, or the ISR, and we will be writing these drivers on x86 machine as well as on BeagleBone Black and Raspberry Pi. So this is the serial driver. Then coming to the I2C drivers, so here we will be writing I2C client drivers for RTC as well as the EEPROM that will be connected through the BeagleBone Black externally, and we will be writing a driver by using this I2C interface. So these all things what we are talking about, these all things will be we will be having a hands-on, and we will be working on Raspberry Pi, BeagleBone Black, along with all the external peripherals will be connected with that, and we will be writing a driver for that. Then we will be knowing about the memory mapping and DMA, how DMA works in the Linux, and how to write a drivers that is mapping kernel memory to the user space. For that we are doing hands-on with memory map driver we will be writing. So then we will be knowing about the block drivers. So here we don't have the actual hardware, so we will be doing we will be writing a RAM rich drivers. On that we will just see how the block driver works. Now coming to the PCIe driver. In the PCIe driver we will be writing a PCIe driver for PCI DIO card, and that is having 48 IO lines. For that we will be writing a PCIe drivers. That driver we will be writing on x86 machine because our BeagleBone Black or Raspberry Pi does not have the PCI interface. So we will be writing this PCI driver on x86 architecture for the PCI DIO card. After that, in USB driver we will be knowing about the USB architecture, the USB, and we will be writing the USB to serial driver that will be connected to the BeagleBone Black as well as Raspberry Pi and x86 architecture all together, and we will be also doing hands-on with USB webcam drivers. Then the next topic is chapter 18 is the network drivers. Here we will be knowing about each and every part of network driver, like we will talk about how the application will land to the TCP/IP stack and how TCP/IP stack forward those all calls to the Linux drivers, because network drivers is entirely different than the way we write a character and block driver. So here we will be having hands-on with PCI based Ethernet card, that is a Realtek card, and we have a SPI based Ethernet card, SPI 9000. 9000 there is one chipset. For that we will be writing a Ethernet driver. So the SPI based Ethernet driver we will be writing for BeagleBone Black, and the PCI based Ethernet card driver we will be writing for x86 architecture. So after completing all these character driver, block driver, network drivers, we will be knowing, before that also we need to know how to port our drivers to the target board, like the ARM architecture, that is BeagleBone Black and Raspberry Pi. So here we will be knowing about the cross compilation steps and the Linux startup sequence. In the startup sequence we will know, like from the scratch, if you want to start any work, so how to go ahead with that. So what is bootloader, what is xloader, what is Linux kernel, how to configure the kernel, how to compile the kernel, then how to create your own root file system, how to write your application in order to test all the drivers, and cross compile those things and put it to the box. So first chapter is cross compilation and Linux startup sequence. The second chapter is introduction to bootloader. So here we will be knowing about the U-bootloader, because U-bootloader is being used in most of the products. Then bootloader compilation, porting to the target board. Then the OS architectures, in that how we will learn about how to customize the Linux kernel and how to cross compile the kernel to get the kernel image and put it to the box using the TFTP or serial or USB interface. Then after cross compilation of the Linux kernel, we will be knowing about BGBox. What is BGBox? What are the things BGBox provides? and by using the once the BGBox is cross compiled, then we will create our own root file system and we will put it to the box. So these are the topics we will be covering here, and the last topic is debugging, like how to debug our drivers or how to debug our kernel in case anything goes wrong. So for that we will be using POCFS and SysFS to get some information from the driver, as well as we will be seeing like how to use GDB and KGDB. So this is the Linux device driver syllabus, and if you want to know more about this topic, then you can call to this number, or you can send mail to support@lavinfo.com in order to get more information about this topic. And for professionals who are working, if they want to go for weekend classes, then it takes around 8 weekend classes. So it means 2 months of time. And for a person, those are freshers, or they want to go for a weekdays classes, then it will go for 1 week, month of time. The regular classes from Monday to Friday, it will go for around 1 month of time. So you will enjoy a lot over here. You have lots of hands-on to do. So that's it from my side.